Let's look at a little bit harder problem. Here we have f of x and g of x, both are rational functions, and we want to find and simplify g of f of x and then find its domain. So what does g of f of x mean? It means g of f of x. It means g of 1 over x plus 2. That's our f of x. This means everywhere we see x in the g function, we're going to replace it with 1 over x plus 2. So we have 4 over, parentheses, 1 over x plus 2 minus 1. So there's our g of f of x. But this isn't very simplified, so we may want to simplify it by taking care of this complex fraction. We need to start by getting a common denominator down here. The common denominator is x plus 2, so we're going to multiply the top and the bottom of that 1 by x plus 2, giving us 4 over 1 minus x plus 2 all over x plus 2. And so this is 4 divided by 1 minus 2 is a negative 1 and a negative x and a x plus 2 in the denominator there. Well, since we're dividing 4 divided by, we need to take the reciprocal and multiply. So this leaves us with 4 times x plus 2 divided by negative x minus 1. Alright, so we have found and we have simplified g of f of x. So we want our domain next. The domain of a rational function is all real numbers except for the values of x that would make the denominator 0. So what would make the denominator 0? If x equals negative 1, the denominator would be 0. So we want x to not equal negative 1. Now in the previous problem we said the domain was anything that causes problems in our simplified function needs to be excluded. But then we also said that anything that causes problems with the inside function, in this case that is f of x, those have to be excluded as well. So looking back up to f of x, which is 1 over x plus 2, I need to look at 1 over x plus 2. Are there any values that would cause problems? Yes, x cannot equal negative 2 from this problem, so the domain is all real numbers but not negative 1 or negative 2. What other types of problems do we have to worry about domains? Polynomials, we don't really have to worry about domains because domains of polynomials are all real numbers. Rational numbers, rational functions, the domain is all real numbers except for what causes the denominator to be 0. One other type of functions that we typically deal with are root functions. So what if f of x is equal to the square root of x plus 4 and g of x is equal to x squared minus 3. So what is f of g of x and what is its domain? F of g of x means everywhere we see x in the f of x function, we are going to replace it with g of x. So we have the square root of x squared minus 3 plus 4. So here we can simplify this, combine some like terms. The square root of x squared minus 3 plus 4 is the square root of x squared minus 1. Now, in order for this radical to be a real number, what's underneath the radical has to be positive. That is, x squared minus 1 needs to be greater than or equal to 0. We worked some of these types of problems in the last chapter, and the way we did it was we factored and found the values of x that cause this to equal 0, positive 1 or negative 1 in this case, and then we thought about a number line for this problem. Well, we know what x squared minus 1 looks like. X squared minus 1 looks like the parabola, like that, with intercepts negative 1 and positive 1. So what do we want? We want to know when the parabola is above the x-axis. So that would be when x is smaller than negative 1 or larger than positive 1. So in this problem, our domain is from negative infinity to negative 1, inclusive, because it's okay to take a square root of 0, that would be fine, union from 1 to positive infinity. Again, it would be okay to have x equal 1 because 1 squared minus 1 is 0, and it's okay to take the square root of 0. And there is my domain.